Okay, continuing on with Unit 4 practice test number 12. A, B, C, and D, we have to list the 4 line segments that we learned this unit and their points of concurrency. Number 1, from a vertex to the opposite midpoint is a median. And the point of concurrency of a median is the centroid. All right, B, these lines are altitudes. And the point of concurrency of an altitude is the orthocenter. All right, these are perpendicular bisectors. They're perpendicular to the side and they bisect the side. Notice it's the only one that doesn't pass through a vertex. So that is a perpendicular bisector. All right, perpendicular. And the point of concurrency of a perpendicular bisector is the circumcenter. And finally, this is an angle bisectors. These are angle bisectors. And the point of concurrency of the angle bisectors is the incenter. Okay, and you're going to have to know the 4 line segments and the 4 points of concurrency on the test. You have to have those memorized. Okay, number 13. AE, or line segment AE, is an altitude of triangle JAN. So I'm going to go ahead and put that. Shows that it's an altitude. Which of the following must be true? JE is congruent to EN. That is not necessarily true. It could be, but it's not necessarily true. AE is perpendicular to JN. That is must be true. Let's check out the others. AJ is congruent to AN. That doesn't have to be true. And angle JAE is congruent to angle NAE, and that doesn't have to be true either. Okay? You have to know the aspects of all 4 of those line segments. Okay, moving on to number 14. Given triangle ABC, where D, E, and F are the midpoints of the sides, so let's show that by, okay, and you should know by now that means that these 3 line segments are mid segments of the triangle. And if DF is 2x plus 10, and we're just going to put a little arrow out here, 2x plus 10, that's a mid segment. And let's see, if AB, that's this length here, is 5x plus 8, find AE. Okay, that AE. Now, we know that AE is the same length as DE because DE is half the length of AB and AE is half the length of AB. But to solve for x, what we're going to do is we're going to double DF, multiply it by 2 so that it's equal to AB. Because we know a mid-segment is half the length of the third side. So basically we could say that 2 times DF will equal AB. So that means 2 times 2x plus 10 should equal 5x plus 8, which means 4x plus 20 equals 4x plus 8. I'm going to subtract, excuse me, I wrote something wrong. This should be 4 and that should be 5. I'm going to subtract 4x from both sides, leaving 4x. That will go away. 4x from here leaves just x. I'll subtract 8 from this side, which means I have to subtract 8 from this side, leaving 12. So x equals 12. Now when I plug that back in, I'm looking for the length of AE. Now I know AE is equal to DF, so I'll just simply say that AE is equal to 2 times 12 plus 10, or 24 plus 10, or 34. So AE equals 34. Okay, moving on to number 15. If LJ, here's LJ right here, equals 5x plus 8, and JM equals 9x, and KN equals 7x plus 6, find x. Well, to solve for x, we're going to have to set these two equal to each other because we're told they're equal by those 2 point lines of congruency. So I'm going to write this as 9x equals 5x plus 8. I'm going to subtract 5x from both sides, which means 4x equals 8, which means x equals 2. Okay, next we need to find LJ. Pretty easy. LJ equals 5x plus 8, so 5 times 2 plus 8, which means LJ equals 10 plus 8, or 18. And LN equals 7 times 2 plus 6. So LN equals 14 plus 6, or 20. Okay, moving on to number 16. The value of y and the measure of, or find the value of y and the measure of angle HEF. All right, well, let's start with y. All right, we know that EG is a perpendicular bisector of HF, and we also know these two guys are congruent, which means we have these two smaller triangles, EGH. Triangle EGH is congruent to triangle EGF, which means corresponding parts of congruent triangles are congruent, so we know that angle HEG and angle FEG are congruent. So I'm going to say that 4y equals 2y plus 18. Subtracting 2y from both sides gives us 2y equals 18. Dividing both sides by 2, we have y equals 9. Okay, so we solve for y equals 9. And then we're asked to find the measure angle HEF. HEF, that's that whole angle. So what we're going to do is, we know half of that angle is 4y, so we're simply going to say that the measure of angle HEF equals 2 times 4y, or the measure of angle HEF equals 8y, which means 8 times 9, which means the measure of angle HEF equals 72.